So good morning students, good evening students. So today we are going to study optics. So optics. Okay. So what is optics? What is optics? Optics का मतलब क्या है? Anybody? What is Rishabh? Rishabh, what is optics? Hmm? Optics क्या है? Nothing. Any blind guess? Nothing, you know. You haven't heard this name, optics, anytime. Devika?
It is related to rays or something.
Related to?
Rays.
Yeah. Close. Very close answer. Devika, what about you? What do you think? What optics is about? Devika?
Sir, something related to light.
Okay. Very close. Somebody said ray. Somebody said right. Light. Are the only? Is this only thing? Hmm? Optics. Optics किसके बारे में है?
Sir, infrared light.
Hmm?
Infrared light.
तो आपने सुना है वर्ड कॉल्ड ऑप्टिशियन सुना है आपने? ऑप्टिशियन सुना है? ऑप्टिशियन नहीं सुना जो चश्मा बनाता है यार, चश्मा बनाता है, ऑप्थेल्मोलॉजी सुने हो? सो अगर मैं डेफिनेशन बताऊं व्हाट आर ऑप्टिक्स. ऑप्टिक्स इज नथिंग बट इट्स अ साइंटिफिक स्टडी. यू कैन राइट डाउन. इट्स अ साइंटिफिक स्टडी ऑफ साइट. साइट मतलब देखने का, देखने का साइट. मेरा साइट ठीक है, मेरा साइट खराब है, ठीक है ना? एंड द बिहेवियर ऑफ लाइट. Okay, or you also may say it is a property of how light transmits and deflects. मतलब कैसे जाता है लाइट, ऐसे गया, हिट करके वापस आया, इधर हिट करके वापस आया. एक मिरर है, यहाँ पर मैं खड़ा हूँ बार्बर के शॉप में. आई कैन सी मल्टीपल इमेजेस. Yes or no? When you stand in a barber shop, two mirror, you stand in between, you can see infinite number of mirror images. Yes or no?
Yes, sir. Yes, sir.
So it is a study of light, behavior of light, how light propagates in different medium. सब कुछ मिला के तो obviously मीडियम की बात होगा, ग्लास की बात होगा, लेंस की बात होगा, everything. So everything we say it is called optics. Is it clear? Any doubts in this?
Yes, sir.
Okay. So now when you talk about optics, the major thing is light. Light. What is light? What is so important of light? What is a light actually? If I say what is a light, somebody say light is a something like source. Somebody say it is a energy. Somebody say it is a wave. Somebody say it is a particle. Yes, yes, they are energy, they are a particle, they are wave. Source you may not say. So when you say particle, what it is? The particles are called photons. Have you heard about this?
Yes, sir.
They are called photons. And if I say wave, they are called electromagnetic wave. Lights are electromagnetic waves. And if I say energy, yes, light is a type of energy. When I say light of type of energy, so are there different type of energy? Yes, we have wind energy, we have solar energy, we have hydroelectricity, mechanical, chemical, wind, anything. So they are all different type of energy. So energy, if I say the whole energy of the whole universe is constant. However, if I say light energy is being produced, if you are glowing a bulb, what do you mean by that? The bulb is glowing because electrical energy is being consumed. I am consuming electricity, and that's why the bulb is glowing. That means the electrical energy is being converted into light energy. Similarly, if I say fan is rotating and fan is giving you what? Wind. So then you say the electrical energy is first getting converted into mechanical energy, and then mechanical energy is being converted into the wind energy. Because of electricity, the fan is rotating, the motor is rotating, and the winds and the wings are rotating, and because of the rotation of the wings, we are getting wind energy, and you feel cool. Is it clear? Is it clear?
Yes, sir.
So I think you look like what do you call that? Rishabh, you look very tired. You look very tired. You know, no josh in your voice. Why so?
क्लासेस था ना अभी
इतना घंटा क्लासेस क्या चल रहा है? Okay. So that means, but when I said light is a wave, light is a particle. So obviously light is a type of energy. But when I say light, light can be broadly classified into two. One is wave and one is particle. Light is both a wave and a particle. Light is energy, and not say, but light can be a wave, can be a particle. But you say, sir, how can it can be both? Yes, it is both. So there are experiments which proves that light is a particle, and there are experiments which proves that the light is a wave. So light is both particle and light is both wave. Is it clear?
yes sir
Is it clear, Devika?
Yes, sir. Yes, sir.
Okay. So nature of light. Nature light. When I say what is the nature of Rishabh, I will say Rishabh is very moody, or very intelligent, or very clever, or he is angry man. So these are nature. When I say light, light is a particle, light is a wave, light travels in a straight line, light reflects on when they find objects, or light passes through the transparent objects like transparent or translucent, or if you put a some kind of mirror which is not silvered, a mirror glass piece, if you put a glass piece, window glass piece, light will travel and go. But similarly, let's say you put a mirror, if you put a mirror, then light will go and rebound back. This is called reflection of light. Light also refracts. Yes, if you put a glass slab, the light will go like this, but it will go like this. Why does it? Light will bend. Similarly, when you have different mediums, so we will study about all that slowly, about how the light propagates, and what are the different type of optics. One is called the optics. Optics will be basically classified into two. One is called ray optics, which I think you have in your syllabus right now, and one is called wave optics. As per Maharashtra State Board, this is there in your 12th class. I think ray optics is part of 11th class. But in CBSE, both are there in the 12th board. But I think in Maharashtra, ray optics is there in your 11th, and 12th you have wave optics. Is it clear?
yeah
Clear? When I say ray optics, what do you mean by that? What do you mean by that? Ray optics means we are talking about ray, light as a ray. Light is not like a curve, no, light is a ray. That means light travels in a straight line. Light propagates in a straight line. There is a source, there is some source which is sending all rays in all direction. Light travels in a straight line, after hitting also goes back at a straight line. It is not that light comes like this. Is it clear? So what we will study as part of ray optics, we will study what is reflection. We will study what is refraction. Okay? And we will study what is total internal refraction. We will study all this as part of ray optics. Is it clear? Is it clear?
Yes.
Then we will study what are, as part of wave optics, which is not now. We will study what is interference. Interference, Huygens law, diffraction, Fraunhofer diffraction, Fresnel diffraction, polarization, Brewster's law, and various things as part of wave optics, which not now, we will study in 12th class. Clear? And also we have Doppler effect, so many other Doppler effect. Yes, clear? And then we will study what's the particle nature. Particle nature. This also is there in your 12th class. In the particle nature, we have photoelectric effect. Have you heard about this?
Yes, sir. In 10th standard.
Yeah. Then is Crompton effect. Then you have Davish and Germer experiment. Davison and Germer experiment. Clear? And we will also study classical wave theory. So this forms as part of particle nature. Is it clear? So I'm just giving you a brief about what is what. We are not going inside right now. So is it clear? Light can be divided into two theory. One is called the particle. One is called the ray optics. One is called the particle theory, and one is called the wave theory. Clear, guys?
Yes.
Any doubts till now?
Yes.
No.
Devika, clear?
Yes, sir. Clear.
Okay. So when I say light, so obviously it has a speed. Yes, it has a speed. What is the speed? Light travels when it goes in different medium, like in water, in air, in vacuum, in honey, anywhere, honey, in a glass, in a solid, any solid. It can be metal, iron. So they have different speeds. So what we are going to remember are two things. One is called air, and one is called vacuum. The light has the fastest speed in vacuum, that is 3 into 10 to the power 8 meter per second. Similar, light has 2.9 into 10 to the power 8 meter per second. So can you see a little difference? Air, the speed of air is less than speed of vacuum. Yes or no?
Yes, sir.
Yes or no, Devika? So the speed of air, light in air, is lesser. Why? Because air has vacuum. Does what do you mean by vacuum? Vacuum means nothing is there. Absolutely nothing. It is completely empty. But when you say air, it has all the different. You have wind. We have air. We have a lot of gases. We have, let's say, atmosphere. We have dust, water vapor, everything. So that means when you say, when I give you two things, when I tell you Devika has to travel in a empty road. Similarly, but at Rishabh, I will tell Rishabh, there are some 100 people going. Rishabh has to reach here. So if both goes in the, who will feel easy to go, Devika or Rishabh?
Devika.
Yes, absolutely, because Devika is getting a free road, but Rishabh is not getting a free road. Similar thing. Light in vacuum is like a free road. It can propagate very fast, but in air it takes time. So remember, light from sun reaches Earth in 8.33 minutes. Are you aware? But you know that around Earth there is atmosphere. Yes or no?
Yes, sir.
So that means light till atmosphere travels very fast at 3 into 10 to the power 8. But moment it enters Earth atmosphere, it slows down. Why? Because this is air. Air is there. And in air, light will travel slower. But till now, till atmosphere, till this much, light travels 3 into 10 to the power 8. But moment it enters, it will move in this format. So what we are going to remember for our problems mostly about this one. Unless or until any specific problem comes on this type of mediums, they will give you that use light speed in water is this much. But normally, if they don't give you anything, you may take this value. You may take this value. Is it clear?
Yes, sir.
Devika, clear?
Yes.
So when we go to ray optics, what do we consider? We have also learned that light always travels in a what? Straight line. Yes or no? Have you seen light bending? No. No.
No, sir.
Light always travels in straight line. After hitting goes like this. After hitting goes like this. But straight line. These are straight lines. These are reflection happening. Rebounds. Straight line. Straight line. Straight line. Clear? Yes or no?
Yes, sir.
In a homogeneous. What is a homogeneous medium? Homogeneous means it is same. If I say air means air in India or air in a particular place, let's say Airoli or Gansoli, is same. That means whatever humidity I feel at my home, you will feel the same in your home. Air is homogeneous. Homo means same, homogeneous, evenly distributed. And when I say isotropic, that also is same, isotropic medium. Clear? Clear? The properties of air is same in all directions, irrespective of the place. So if it is a homogeneous medium, then your light will travel straight. But let's say this is not homogeneous, it will vary, then probably light will bend. Maybe. But normally we see the light is travels in a straight line. That's why it's a homogeneous medium. For us, it travels in a straight line. Is it clear?
Yes, sir.
Yes, sir.
Okay. Next point. Next point. Light, two or more rays can intersect at a point without affecting their path. Means, if I send one ray like this and one more ray like this, so after meeting, do they change their path? No, they still travel in their path. It is not that they are coming after meeting they are going like this. Is it happening like this? No.
No.
They are continue to go in this direction and this also continue to go in this direction. So even they meet or they intersect each other, they do not change their path. Clear? Yes or no?
Yes, sir.
Next is
Yes, sir.
light follows laws of reflection. What do you mean by reflection? What are the laws of reflection says? The laws of reflection says that if I have this is a surface, if I send one light like this light is called incident light. What light? Incident light. I will have a reflected light, or you may say reflected ray or incident ray. If I draw a normal, that means a line which is perpendicular to the surface, then the angle this perpendicular is said to be normal.
Yes.
The angle between this one and the incident ray is called the angle of incidence, and the angle between the normal and the reflected ray is called angle of reflection. So the first law states that angle I is equal to angle R. Clear? Yes.
Yes, sir.
Second law states that both incident ray, incident ray, reflected ray, and the normal all lie on the same
On
plane.
plane.
This is the laws of reflection. Clear? Clear?
Yes.
Yes, sir.
Next we'll come to what is refraction. What is refraction? Laws of refraction. What is laws of refraction? Who will tell me? Yeah. What is laws of refraction? Already studied? Come on.
Sir, the angle of incidence, angle of reflection, and normal lie on same plane.
Okay. So refraction, when you say refraction, see, laws of refraction happens only in one medium. Understood? Only in one medium. This is one medium only. Whatever is this is only one medium. No different medium. But refraction happens in two medium. This is the interface or the separation. This is air. This is water. So here also you have a normal. But if you have an incident ray coming like this air is called rarer medium. What medium? Rarer medium. Or the density of this medium is less. This is called a denser medium. What medium? Means the density here is more than the rarer medium. Whenever any light ray goes from a rarer medium to the denser medium, it will bend towards the normal. If any ray goes from the rarer medium to the denser medium, it will bend towards the normal. Similarly, I can say that if there is a ray which goes from a denser medium to rarer medium, in the ulta, this is denser medium, this is rarer medium. If any light goes from denser medium, it will go away from normal. Like this is air, this is water. You are inside water. You are inside water and focusing light. Okay, it will go away. You see, actually, if there was no medium different, the same light would have gone like this. Similarly, it would have gone like this. That means the light ray is changing their path. They are changing, they are bending. Here also it is bending. Yes or no?
Yes, sir.
Devika, clear?
Yes.
And hence,
Yes, sir.
this angle is called incident angle. The angle between the normal and the incident ray. And this is the normal and the reflected ray. This is the reflected ray. This angle is called angle R. Similarly, here you have angle I. And this angle, not this one, this angle, whole thing is called angle R. So here, your angle I, okay, angle I, okay, sine I by sine R is equal to a constant which is called mu. If you take sine of I and if you take sine of R, if you divide that, you will get a ratio, and that ratio is called refractive index. Clear or not?
Yes, sir.
Clear, sir.
And this law is called Snell's law. What law?
Yes, sir.
Sine I by sine R equal to mu. Very, very important. Clear?
Yes, sir. Clear.
Okay. So now I will do a small problem they are given in a book. A thickness of the glass slab of a spectacle is 2 millimeter. Glass slab of a spectacle. आपका एक spectacle है, मे बी दादाजी का spectacle है, जिसका मोटापा उसका जो thickness 2 millimeter है. 2 millimeter मतलब कितना? 2 by 10 centimeter. Yes or no?
Yes, sir.
The refractive index is 1.5. The refractive index mu कितना है? 1.5.
1.5.
This is refractive index does not have any unit. It is a constant value. Clear? Calculate the time taken to cross this thickness. If I send a light ray, how much time will it take to come outside? How much time will it take to come outside? Is it clear? Is it clear?
Yes, sir.
Okay. So when I say refractive index, the refractive index is 1.5. What do you mean by that? What do you mean by that? It means uska formula, what do you mean by refractive index? Refractive index is nothing but speed of light in air, in vacuum, divided by speed of light in medium. Medium means any medium. So here, what is the medium? Glass? Yes or no?
Yes.
So here, if I say I have to find what is the speed of light in glass, so here medium is glass. This equal to 1.5. If I want to find this quantity, so let's say speed of light in vacuum is, let's say c, and speed of light in glass is cg. Then can I write c by cg is equal to 1.5?
Yes.
So I have to find what is cg. So can I write cg equal to c divided by 1.5?
Yes, sir.
So what is the speed of light in vacuum? You know that 3 into 10 to the power 8 meter per second divided by 1.5. Yes or no?
Yes, sir.
So what is 3 divided by 1.5? It is 2. So your answer is 2 into 10 to the power 8 meter per second. This is the speed of light in glass. Yes. So now we have to find how much time it took to cross this thickness. That means light has to travel this much thickness. And you know very well that speed is equal to distance by time, or time is equal to distance by speed. Yes or no?
Yes.
What is the distance it has to cover? Thickness. What is the thickness? This is the distance.
2 by 10.
2 by 10. Speed you know. Can't you find time? Yes. Time is equal to 2 by 10 divided by, because it has to be meter. So you have to convert this into meter. So how? 2 by 10 centimeter is 1. How much meter? 2 by 1000 meter. Yes or no? So it will be 2 by 1000 divided by 2 into 10 to the power 8 meter per second. So how? So 2 by 1000 into 1 by 2 into 10 to the power 8. So 2 gone. So what is the time? Your time will be 8, 9, 10, 11. 10 to the power 11 seconds.
11.
So your time will be this much. It's a very big, it's a very small quantity. 1 by 10 to the power 11 seconds. That means 1 में 11 जीरो है, उतना सेकंड लगेगा, मतलब 1 सेकंड भी नहीं लगेगा. Is it clear?
Yes, sir.
Is it clear?
Yes, sir.
Rather we say nanoseconds, 0.1 nanoseconds. Yeah? Okay. So now let's come to what is Cartesian convention. What is Cartesian convention? So whenever, this will be useful for our ray diagrams. Okay, ray diagrams. So what does it say? It says that if this, like you know, Cartesian convention for your what is it called that? What do you call that? Graphs, you know, no, x dash. In your 10th you would have done y dash. Yes or no? Anything above, anything this side is positive. This is the positive quadrant. All the positive. X is positive, y is positive. This side x is negative, y is positive. This side both are negative, and here x is positive, y is negative. Yes or no? Do you remember?
Yes, sir.
So this, now we will study Cartesian convention, because we will study about geometrical optics. And for that we have to understand what is Cartesian convention. So what is Cartesian convention? Cartesian convention says, if this is the initial point, if any light ray goes from here to this side, it will be considered to be positive. If anything goes above this one, this will consider to be positive. If anything goes below this bar, whole bar, it will be considered negative. If anything goes this side, opposite, it will be negative. If anything goes above this, again positive. If anything goes below this, it is negative. And this is called the pole. This is called the pole, or the optical center, Clear?
Yes, sir.
Anything this side, going this side, all positive. Anything going like from here like this side, all negative. Anything goes below this, it is what? Negative. Anything going above this, positive. Clear? Clear?
Yes, sir.
So, and there are some other points also. We have to consider what? First point, write down. Very, very important. All distance are measured from the pole. Measured from the pole. That means if you have this one, this is the pole. If you want to, if there is an object here, you have to measure from here to here. What is the distance? If something is here, then you have to measure from here to here. All distance have to be measured from the pole. Clear? Is it clear?
Yes, sir.
Yes.
Rishabh, I think you are completely down. You don't want to study?
No, sir.
No, I feel that no, it's not good actually, because if you're tired, no, there is no use of studying. So, shall we pause today? We'll continue on maybe tomorrow or sometime.
No, sir, it's okay.
No, I don't feel like teaching, because see, problem is now everybody has to be energized. I am not saying I'm not penalizing you. I'm telling you, you have to give some break to. I don't know why so much time it is taking for you class. So you have to take rest. So I think we have made a good introduction, good cover today. So probably we will teach from next class. Maybe Swarup also is not there. So take rest, Rishabh. Whatever study, give time. Take ample rest. So much studying is not good. Okay.
Yes, sir.
Let us pause today. Yeah.
Yes, sir.
Devika,
Yes, sir.
share the recording and I will upload.